Welcome to education program online with me, teacher Christine Adeko, taking you in mathematics for senior 3 and senior 4. Our topic remains real functions and limits. In our previous lesson, we looked at subtopic, which is the range, how to find the range of a function. And therefore, today we are looking at what we call graphing a function. Graphing a function. Graphing a function. Graphing a function. So this is what we are going to look at it now. Under the same topic of real functions and limits. So when we look at what we call graphing a function, a graph of a function is simply a set of all points whose coordinates satisfy the function y equals to function fx. So meaning that any curve on any graph that is got or that can be drawn, it is determined by the nature of the relationship between the two variables. That is what determines the graph. So you find that the most common relationship of the two variables are including what we call the linear and non-linear functions. Non-linear functions. So these are the most common relationship that always occur under what we call a graphing. So when you look at linear or non-linear, we find that under non-linear we mostly base on what we call quadratic graphs. The quadratic graphs, we have the cube graphs, and then we have what we call the trigonometric graph, and so on. So this is where we are going to base so much on what we call the non-linear graph. So you say the relationship between the two variables, defines the nature of the graph. Defines the nature of the graph. The nature of the graph. Of their relationship. The most common relationship that exists are either linear or non-linear. Either linear or nonlinear The nonlinear include quadratics, comma, we have cubic, comma, we have polynomials, and trigonometry. The trigonometry relationships. So learners, we have just said that when we are looking at graphing a function, for us to get what we call a graph, we look at the relationship between the two variables. And of course, you know the two variables are x and y. So you find that the nature of the graph will be determined by the relationship that occurs between x and y. And these mostly relationships occur on what we call the linear functions and nonlinear functions. So under nonlinear functions, we look at what we call the quadratic functions. And then we have what we call the cubic functions, the polynomial functions, and trigonometry functions, and so on. Therefore, after knowing that, then you need also to know what we call now, what do we mean by a graph function? When we talk of a graph function, what is it by definition? So you say the graph function is a set of all points. Whose coordinates x, y satisfy the function y. The function y equals to fx. Take note of this and be in the graph for each x value for each x value, there is a corresponding y value, a corresponding y value. Obtained by substituting into the expression fx. So learners, this is what we call a graph function. When they ask you define a graph function, we simply know that a graph function is a set of all points whose coordinates, that is the coordinates of x and y, satisfies the function y, and the function y you will be given. So looking at, for you to get the coordinates, or for you to get the what we call the graph function, then you should know what are the coordinates of x and what are the coordinates of y. And therefore, if I'm to get these two coordinates, are they satisfying what is given, the rule which is given? Then now you say it is a graph function if it is satisfying. And then take note in this that for you to get those coordinates of x and y, then you need to have what we call the values of y, values of x. The values of x will always be corresponding with the values of y. What does it mean? It means that for us, we need to get the values of x, which are the domains. Remember the other time when we are introducing the lesson, we say the domain. The domains or the objects. So the object must be given, and therefore if we have the object which is the x-axis, that are for x-axis, then it will become easy for you to get what we call the codomains on the, which is the y-axis. And this one will only happen by you substituting what is given. For example, you'll be given the function, which is the rule. You'll be given the function, and therefore, which we say, if the rule is given, then objectives are, or objects are given. So the object, you get the object, substitute in what we call the rule or the function given. Then what outcome of it is what we call the output, which is the codomain, which is for y value. So let us look at now what we mentioned here, the two graphs, that is the two relations, that is the linear and non-linear. So let us look at what we call the linear graphs. What are they? The linear graphs. Linear graph. So the linear graph, we say a linear graph, these are group, these are group or graphs, group of graphs of the function, whose general format is a x plus b plus b. Where a and b are constant. And b, linear graphs are straight line graphs. Linear graphs are straight line graph. Linear graphs are straight line graph. Straight line graphs. So, dear learners, looking at what we call linear graph, how do we differentiate the linear graph from a non-linear graph? So, the linear graphs you find are graphs of a function whose general format is a x b, a x plus b. So, when you get any function which is given as a x plus b, then you automatically know that this is a linear equation or a linear function. Therefore, when you are drawing all the linear graphs, they mostly consist of what we call a straight line graph. They mostly have what we call the straight line graph. So when you draw a graph and after plotting, and then you find that after joining the lines that you have plotted, and what comes, or the graph appears as a straight line, then definitely you will just conclude by saying this is a linear graph. So let us look at the example of a linear graph. A linear graph. So you say example. Let us look at the example of linear graph. They would say draw a graph. Draw a graph of a function f(x) equals to 2x plus 3, comma, x belongs to a real number. X belongs to a real number. So this is our question. They are asking us to draw a graph of this function. So when you look at this function, you find that it is in the format of a x plus b, which is a linear equation or a linear function. So after identifying that it is a linear function, then you're also going to draw what we call a linear graph. So let us look at it. How do we answer? How do we get the values of x and y? Because for you to draw a graph, you must have values of x and y. So take note of this. First, obtain what we call N3, obtain N3 points of X. N3 points of X. N3 points of X, which is the domain. The domain. And then solve for corresponding Y value. And then solve for corresponding Y value. Corresponding Y value. So in your exams, we don't need you to write this, but this is a notice to you that if I'm given a question in this of this kind, what should I do? I have to draw a graph. They have instructed you to draw a graph, and now for us to draw a graph, we must have the x-axis and the y-axis. Now, what are the values of the y-axis and what are the values of the x-axis? So, then now you come and say, for me to get the values of the x-axis, I will look at my question which is given here. It is 2x plus 3, where 3 is a constant. Therefore, we say, let us take x to be 0. And then we have x to be 1. And then we have x to be 3. X to be 3. X to be 3. So after getting those points, then now we can do what? We can now be able to solve for y. So we simply get our table of values. Table of values. The table of values, we shall have the x and y. So the first one is x, and then this is y, and y is given as 2x plus 3. Then now you say if x is 1, and then if x is 0, and then if x is 3. If x is 1 and x is 0, what will be the value of y? So, dear learners, you look at the object already given, or the domains. So, for us to get the input, the output, which are the codomains, we use this rule. We simply say, I will have f equals to fx equals to the rule, which is x, 2x plus 3. So if x is 1, then you simply get 2 times 1 plus 3, which will give us 2 plus 3 equals to 5. So here will be 5. And then you also come down and say, if x is 0, then what will happen? I will have 2x plus 3, 2 times 0 plus 3, which will give you 0 plus 3. Your answer is 3. So when x is 0, y is 3. And then you move and say, if x is 3, then y will be 2 times 3 plus 3, which will be 6 plus 3 equals to 9. So this will be now 9. learners, after getting the table of values, then now you say points to plot, points to plot, points to plot, that is x, y, x, y. So you correspond these points on the table, which is the first one we have 1 and then 5 on the x, y axis, and then x on the 0 on the x axis and 3 on the y axis, and then we have 3 on the x axis and 9 on the y axis. So after that, then now you can draw a graph. So now you come and say a graph. So our graph, we shall have, this is for y, and then we have the x. We shall have our graph in this nature. So our graph will appear in this nature. So our graph will appear in that nature. Then we say on the y-axis, we say this is our starting point 0, and then we have 1, we have 2, we have 3, we have 4, we have 5. So we have up to 5 on the y-axis, and then we, on the x-axis, we say 1, 2, 3, 4, 5. And then we have -1, -2, -3, and so on. And then -1 on the y-axis, -2, and then -3. So after getting that is your, or drawing your graph, we are now going to plot. On the x-axis, you move one step, that is here. So when you are here, you move on the y-axis is where you are going to plot. So you follow this straight line of 1 up to where 5 is, and then you mark it there. And then you come to this. This is 0 on the x-axis, and on y-axis is 3. So you stand here exactly where 0 is, and then you follow the straight line on the y-axis up to where 3 is. So you find that 3 is there. And then we have the 3 on the x-axis, which is this, and then the 9 on the y-axis. So our whiteboard is somehow small, so we assume that the 9 is lying somewhere here. So after you have done that, then you can now join your line. You join those points. You join those points. So you will find that the curve, the line is, the points are lying on a straight line. And then now you say this is a linear curve. This is a linear graph. This is a linear graph. So learners, that is how we simply, if asked to draw a graph of a linear nature, of a linear relationship. So this is how you draw. So my dear learners, we have looked at how to draw a graph of a linear function, and I hope you have picked something on this. Take note of this as we are ending our lesson. If you are asked to draw a graph of a linear function, first of all, obtain if the points are given, the values of x are given. Solve the values of x by substituting in the function or given, so that you can be able to get the y value. So after that, you draw your table of value and you pair them up. So as you pair them, it will enables you to get the points to plot. And then lastly, you come and plot your graph. And when after plotting, make sure that you join the line, the points. So with this, learners, we have come to the end of our lesson for today, and I wish you the best. I hope we shall continue from here when we meet for the next lesson. Goodbye.